It starts quietly. Millions of infected devices lying dormant in our homes, offices, even inside everyday gadgets, all waiting for the signal. Then, in an instant, they are waking, unleashing a relentless tsunami of data that slams into networks and servers, choking them, breaking them, and shutting out the world. This is a DDoS attack. A DDoS attack, short for Distributed Denial of Service Attack, is a cyber attack in which multiple devices, often thousands and millions, work together to overwhelm a target, which could be an online service, a network, or a computer with massive amounts of traffic or requests. There are three main categories of DDoS attacks, and the first one we are going to be bisecting is the protocol-based DDoS attack. And for those who might not be familiar with the term, a protocol is a set of rules that computers use to communicate with themselves over a network. Just like we use language to communicate with one another, computers use protocols to ensure that all devices on the network speak the same language and can exchange information smoothly and accurately. Protocol-based DDoS attacks take advantage of the way network protocols work. So instead of flooding a site with raw traffic, attackers use cleverly timed requests to fill up a server's connection table or CPU, making it too busy to respond to legitimate users. You can think of it like jamming a phone line so that no one else can call through. A typical example of a protocol-based DDoS attack is the TCP SYNC flood attack, which targets the handshake process of TCP. TCP stands for Transmission Control Protocol and is one of the main protocols in the Internet Protocol suite. It ensures that data is sent reliably between two devices by using a quick three-step handshake process before they start talking. To understand how the TCP SYNC flood works, you have to understand how TCP connections are made on the internet. A TCP connection is made using the three-way handshake. It's just like a friendly conversation between two devices before they start sending any data between themselves. In this process, the client sends a hello message called a SYN packet or synchronization packet. The server receives this message and responds with a SYN ACK packet or synchronization acknowledgement packet. The client receives this SYN ACK packet and responds once again with an acknowledgement packet, confirming that it has received the response from the server. Now, connections can be made and both can send data between themselves. In a SYN flood attack, the attacker fires lots of synchronization packets but never sends the final acknowledgement packet. The server replies and reserves resources while it waits for the final confirmation message, which never arrives. Repeated at scale, this exhausts the server's connection slots and resources, leaving legitimate users logged out and services unable to function properly. The second and most common category of DDoS attacks is the volume-based DDoS attack. The goal of a volume-based DDoS attack is to saturate the target's network bandwidth by flooding it with enormous amounts of traffic. As the links become congested, legitimate requests can't get through, and services slow down or go offline entirely. In short, the attacker simply drowns the target in traffic to disrupt access. A typical example would be the UDP flood attack. UDP stands for User Datagram Protocol, and it's a protocol that is used for fast connectionless transmission of data. In a UDP flood attack, the attacker sends massive amounts of UDP packets to the target network. Unlike TCP, UDP is connectionless, meaning that it doesn't require the three-way handshake to form a connection. This means that the servers in the network will not check to see if the packets are coming from a legitimate source or are part of a legitimate session. With a flood of incoming UDP packets, the target server's resources such as bandwidth, CPU, and memory become overwhelmed, which lead to denial of service for legitimate users. The third category of DDoS attacks is the application layer attack. The aim of this attack is to overwhelm a specific web application or service by sending lots of legitimate looking requests. A common example is the HTTP flood attack. Here, the attacker uses a botnet, which are thousands of compromised devices, to send massive amounts of HTTP requests to a target page or API endpoint. Each request forces the server to use CPU, memory, and database resources to process and respond. What makes this category of DDoS attacks hard to stop is that they look like normal traffic. So simple rate blocks can accidentally block legitimate users. So cybersecurity professionals use things like challenge responses, web application firewall rules, and behavioral analytics to differentiate between bad and good traffic. The most effective single way to protect your network from a DDoS attack is to route your traffic through a trusted DDoS mitigation and scrubbing provider. Example, Cloudflare. They spot and remove malicious traffic in the cloud, keeping your servers online even during very big attacks, which is far more effective than trying to handle massive floods on your own. In the next video, I'll be taking you through a hands-on lab so you can see for yourself how a DDoS attack works. So like and subscribe so you don't miss out on that.